Hi, from now I'm going to start signing out, saying specifically which family belongs to the case we are dealing with. Now, before actually showing you the case I'm actually going to solve, I'm just to recapitulate a bit. This was actually the first example that we solved on the first video. Now, on that video, we solved it the long way using the formula for integration by parts, identifying an u and a v prime. Maybe it wasn't so clear which has to be the u and which has to be the v prime. Now, I'm going to give you a few hints of how to identify which one should be one. Now, this case clearly falls into the case number one of these families of integrals. We can identify it because we have an x raised to an n power, which in this case is 1, even though it's not written. The thing is, this n has to be a whole positive number, and clearly this falls into this case. Now we have an e raised to the a times x. Now a has to be a number as well, a constant. So even though here's not written, it's a 1, so it falls into it. Now, this is very important, the next thing. This x, which is in the exponent of the e, has to be linear. That is to say, it has to be without any exponent. So it clearly falls into this one, this case. Now I'm not going to solve this out fully. I'm just going to show you the answer using integration, this tabular method. There is the solution. I use here the tabular method. It's such a quick way. Now actually the example I'm going to show you here, which is a kind of an explanatory one, is I'm going to show you what if we change a bit this original statement. What if we change a bit this one? What if instead having x times e to the x, I would have something. I'm going to use actually a different color, but let me use, I'm going to use, what should be good? I'm going to use this green one. Yeah, I'm going to use this green. So instead of having x times e to the x, I'm going to have x to the third times e, it's a very ugly e to the x squared dx. Well, just by looking at the exponent of this e, we can notice that we are not falling into this first case of these families for integration by parts. Luckily, we learned on the past topic how to use this changing the variable. So I'm going to show you what happens if you add up these two terms, these two topics. So I'm going to actually pick to be, I want to make a change of variable, use substitution. I'm going to pick to be u the exponent of the e. So I'm going to pick u to be equal to x squared. I'm going to take the derivative of this one, so it's going to be here du, oh, it's a very ugly u. There, du over x is equal to 2 times x. Now I'm going to solve for this dx, so it's going to be looking like this, okay? So I'm going to substitute. I'm going to have here this x to the third times e to the u times du over 2 times x. Now let's see, we can simplify things because we can simplify this x and we can simplify this to be x to the 2, the second power. So we'll get to this. I'm going to move outside of the integral this 2 as a 1/2, as this 2 is dividing. So we have 1/2 times, the integral of x squared times e to the u du. Now this, we have two variables, so we have to deal with some way to take away this x squared. Luckily, we just took to be u, a new variable, be equal to x squared. So we can actually substitute this information in our statement. It's going to be 1/2, it's very ugly 2/2, the integral of u, but here u equal to u times e to the u du. And surprise, surprise, so we can see this. I'm going to frame it actually because it's so cool, this part. This one, it's actually the same as the previous case. I mean, we have a different letter, but it's actually exactly the same case, as you can see. Now, we can assume that this result will be something equivalent to this one. So I'm actually going to use this model to quickly solve this one. I mean, of course, we have to solve this out using the tabular method, but I'm just going to copy it here in a moment. Let me see. I just wrote here on the right this this table is going to look. As you can see, it's pretty much the same case, exactly the same actually, the first one we solved. So I'm going to use that information now to solve the second one. So now remember, this whole expression is multiplied times 1/2. So this will look like this. It's going to be 1/2 times, it's going to be u times e to the u, and there would be minus e to the u. This will be plus c. Now the only thing that's going to change here is we have to multiply this 1/2, and just to show you how cool it is. EU to the e to the u minus e to the u plus c. And now the thing is, we started with x as a variable, so we should end as well to x. So we have to unsubstitute the u because we were mixing up the two topics that we previously learned. So this is going to turn to be x squared times e to the x squared minus, it's going to be here, minus e to the x squared plus c. And there it is. This is the solution for this second integral. We were struggling kind of here at the beginning. This one, it seemed like it didn't fall exactly into this family number one, but by using change of variable, which is what we did here, by using the change of variable or u substitution, we transform this initial case into something that was actually in a sense the same as we did with this previous first example. So keep this in mind. So it may not fall into the exactly into the form of the family, but we can use some of the tools like changing the variable to make them fall into these families. So let's go to the second example of these mixing topics, integration by parts and change of variable. Oh, here, I'm sorry, I have to correct, I forgot to multiply the second term by 1/2. I'm so sorry. This is so embarrassing. It's this has to be 1/2 e to the u plus c, and I have to do it in the previous step as well. X squared plus c, and I have to solve it as well here. It's going to look like this: 1/2. Here was e to the u plus c, and yeah, I guess there it is. Let me see. Yes, there it is.